Welcome to our final year project, Design and Development of a Prosthetic Hand for American Sign Language Translation. These are the team members who worked hard on this project. We thank our guide for their support and valuable guidance throughout. Together, they made this project possible. This project is developed for individuals with hearing and speech disabilities. It translates typed alphabets into ASL gestures using a prosthetic hand controlled by an Arduino microcontroller and a matrix keypad. Problem statement. Many assistive devices for sign language are expensive or limited. Our goal is to create an affordable, educational prototype that helps bridge the communication gap through simple electronics and gesture-based outputs. The keypad has 16 buttons, each one mapped to a unique gesture. When a key is pressed, Arduino reads the row-column signal and rotates the linked servo motor to move a specific finger. When key A is pressed on the keyboard, the prosthetic hand performs the gesture for the letter A in American Sign Language. Similarly, pressing key B triggers the hand to form the ASL sign for letter B. At this stage, all connections are properly done, and the system is fully functional. Each key press sends a unique signal to the Arduino, and we get different finger movements as output. For example, pressing A, B, C, or D gives different servo responses, though not yet perfectly matching the ASL gestures. Still, this proves that our setup is working and responding accurately to individual key inputs, a key step toward real-time gesture translation. Our aim is to create a low-cost system that can translate key inputs into hand gestures. In future, we plan to fine-tune the servo angles for accurate ASL gestures. We also aim to include more letters and eventually full word translation using input combinations. This system offers several advantages. It is low cost and made with easily available components. Simple keyboard input makes it user-friendly. Custom gestures can be programmed as needed. It supports modular upgrades like gesture correction or full hand sign translation. It can help bridge communication gaps for individuals using sign language. In the future, we aim to refine servo angles for accurate ASL gestures, support more keys, and explore real-time gesture learning using sensors or vision-based input. Thank you for watching our project demonstration. This is a step towards affordable gesture-controlled prosthetics for communication support.